Okay, so it is official now. We have 4 theorems that tell us certain things are equal to each other or add up to 180. In other words, are supplementary. So, for example, 1 second, let me get out my annotation. So, the corresponding angles theorem. Corresponding angles, as you'll remember, are ones that are in the same position. See how this one is bottom left and this one is bottom left? Right there. Well, that's a terrible picture. Let's see if we can do better than that. Let's try it with the lines. Okay, so corresponding angles. Now, of course, this is only if the lines are parallel. But if the lines are parallel, the corresponding angles means the ones that are in the same position. See how these ones I've starred are both in the top left? They're equal to each other if the lines are parallel. So in this drawing, 1 and 5, 2 and 6, 3 and 7, and 4 and 8, right? 1 and 5 are both in the top left, 2 and 6 are both in the top right, 3 and 7 are both in the bottom left, 4 and 8 are both in the bottom right. Then we've got alternate interior angles theorem. Same deal, if 2 parallel lines are cut by a transversal, then the pairs of alternate interior lines are congruent. So alternate interior, of course this is only if the lines are parallel. Alternate interior are on inside, but on opposite sides of the transversal. So in this drawing over here, 3 and 6 are alternate interior, so are 4 and 5. Then we have alternate exterior, same deal. I've got parallel lines cut by transversal. Alternate exteriors are on their exterior and on opposite sides of the transversal. Also equal if the lines are parallel. So in this drawing, 1 and 8 and 2 and 7. Then the last one is a little different, consecutive interior angles. Consecutive interior angles, I'm going to use 2 different symbols for. So this angle and this angle, those are consecutive interiors, so 3 and 5 and 4 and 6. They're not equal, but they do add up to 180. They are supplementary. See what they say, supplementary? That means that they add up to 180. That is the essential information for everything you're going to do in this unit. Oh, hold on, let me clear all that. Now let's look at the next page. So we can make equations here. So check this out. We'd know, hold on a second, let me go back to the first one. And okay, no, we talked about that. Okay, so this one, let's see. The measures of 3 numbered angles are 120. Identify the angles. Okay, so if the lines are parallel, then we would know that if this one's 120, so is angle 5 because they're corresponding, right? So is angle 8 because they're alternate exteriors. So would angle 4 be, because look, the angle 4 is vertical to 120. See how they're across from each other like that? So all 4 of those angles would be 120. Oh, I didn't mean to do that. Okay. So check this little situation out. We got, they told us this is 115 and this is x plus 5. Now, there's more than one way to do this. What they realize is that angle 4 plus this angle right here, those add up to 180 because see how they're consecutive interior? But angle 4 is equal to 115, right? Because these are vertical to each other. So they just substituted that in. And then they solved. Let's look at the next one. Similar situation here. We know that these two add up to 180, right? Because this is a linear pair. I can say, now I'm solving it differently than they did, but just check out what I do here. There. Okay, so I know that measure of angle 1 plus 136 is equal to 180. But I know that angle 1 is equal to this one, right? Because these are alternate exteriors. So I'd say that 7x plus 9 plus 136 equals 180. And then from that point on, it's algebra. I've written my equation, solve, solve, solve for x. Now what they did is they said measure angle 1 is equal to this guy right here. And then how they got this 44 is they subtracted. They went, okay, all of this is 180, so that's got to be 44. They subtracted 136 from 180. Oh, didn't mean to go that far. All right, let's see if we got any other questions here. Okay, now, we just talked about that one. Okay, now, proving theorems about parallel lines. Sadly, because we can't cover everything in here, I'm not going to be testing you on proving any theorems, sadly. And which it's especially sad for me because it's like my favorite part of geometry. It was the thing that made me think, maybe I really like math. But it takes a lot of time. It's not absolutely essential for your success in your next math class. So that's where we're cutting. But I do want to give you a taste of it. So check this out. This theorem is about, all right, so this is about proving the alternate interior angles theorem. In other words, how do we know that angle 1 and angle 2 have to be equal to each other? So if the given of a proof is what you assume is true, and the proof is the thing that you have to prove. This statement over here always goes first, and this one always goes last. So the lines are parallel. The reason we know is because we were given that. We said it's got to be. Then we know that, hello, angle 1 and angle 3, just wait, okay? Angle 1 and angle 3 are congruent to each other because they're corresponding angles. That's how we know they have to be equal to each other. But then angle 3 and angle 2 are equal to each other because they're vertical. right? So then what they do is they take this statement, and where 3 is, they insert 1. It's called transitive property of congruence. Think of it as substitution. They took where the 3 is, and they put where angle 3 was, and they put angle 1. Yeah, transitive property of congruence just means if two things are congruent to a third thing, they're congruent to each other, whatever the things are. Their angles, their line segments, whatever the thing is, if they're congruent to a third thing, they're congruent to each other. All right.